Welcome in. So physical quantities and their units. And in this video, I'm going to talk about distance. Now, I'll talk about a few other things, some examples of different kind of distances, the units associated with distance, and then derive and make you think about kind of area and volume as well. So when you're walking into physics, I hope that in the beginning you kind of lay a foundation for yourself of being able to think about these physical quantities, which physics is really all about. It is really just the study of these quantities and then how they interact with each other, so that we can take those quantities and possibly explain certain things that happen in our everyday life, and also possibly predict the future. So that's kind of the goal. So what is this whole idea and concept of distance? Well, I'm sure that you have run into distance, since basically you were a little kid. But I'm not sure if anyone has actually fully out explained to you, what this distance means. Now, as you go through your education, the definitions that you come up with for distance or for anything else will change because your knowledge will change. You might acquire a little bit more, as you're going through. At least that's what we hope, so we get more wisdom. And in my assumption here is that you're at least kind of in, maybe grade 10, grade 11-ish, or maybe, a little bit older. So this concept and explanation of distance should be a little bit easier for you to grasp. So what is this idea of distance? And that's the first item that I want to be able to tackle. So distance, if we would kind of write it out, or at least this is kind of what I came up with, it is some kind of a one-dimensional length measurement. Now, of course, we have to think about what this length measurement is, and it is along a path from one physical point to another. So if you have a sheet of paper like I do right here, so I can certainly say, all right, well, I have one point, let's call this point A, and then maybe somewhere down the line I have another point, point B, and I can say that the length measurement, if I would take a string, I would simply connect these 2 points, and how long, so that's the length, so how long that string is along a particular path. Now I took a straight line path from A to B, and the physical points were the actual points of A and the B on the piece of paper. Now those physical points can be something, which we can think about that I might be completely different, not just a straight line. So you can think of various kinds of distances that you might run into. So for instance, you can take a person, and here I'm going to just draw a stick man right there. So here, if you take a person and you measure, so from the bottom, so let's say from the feet, all the way to the top of the head, as you're going through, you can say that the distance, as you're going along, from the bottom to the top, it's the path from the bottom all the way to the top. And we might say that this particular distance, and we actually give it a specific name, we've actually called it height, especially if it's on the vertical. So that's one example of a distance. Now, there are other distances, that we have as well. If I would maybe draw a box in here. So if I take a box, let's say, let me just draw one for you. And in this case, so the box maybe extends, all the way through here. So we have the box extending, I can just put this in here. So let me just draw it out, connect all these things together. So here's my box. I can also say, so well, my physical 2 points maybe are, from this side all the way to this side, as I'm going through. So this would have been the actual distance that I'm trying to measure from one physical point to another. And maybe, this we would call, because it's the box itself, maybe we would say that this is the width of the box. So, width is another example of a distance that we have. Now, there are further distances that you run into as well, so if you would take maybe, let's say, a tire, okay, and as you're going through, so here's your tire, so let's say, so this particular tire, maybe it's a tire in your car, okay, that you have. Let me try to center this, okay, as best as I can. And our distance in here, maybe it's from the center of the tire, okay, to the outer rim. So we would have a distance, okay, that as we're going through from the center all the way to the rim. And we would say that this particular distance, well, if it's a circle, okay, which a tire, I guess, as best as it approximates, we would say that this might be a radius, which is from the center all the way to the rim. We might also want to be able to go through the center and from one point to another, okay, all the way through. And if it measures the entire, okay, distance, okay, so from one point over here, okay, to another point over here, so if it goes all the way through, we might say that this is another example, and we call that the diameter. Okay, so that could be another one. Now, there's of course many others that you maybe have run into in terms of distances. Maybe you're starting along and you wanted to find out, so you're starting at some point around the rim. Okay, and then you walk yourself around, okay, so all the way through here, so all the way. So we come back and we started at this point and we come back to this point, but we're walking around the tire, okay, all the way through, and we might say that this is the circumference. So these are all examples of various distances: height, radius, circumference, width. And what you notice that indeed we always measure from one physical point to another physical point. And sometimes indeed it's a straight line. Sometimes it might not be a straight line, okay, it might be a curve, as it is with the circumference as you're going all the way through. Sometimes you might have to take a path which goes from the point A to point B, and it may not be, okay, a straight line at all. Maybe you're just zigzagging along, okay, as you get to the other point. But of course, we can take all of these, okay? So for instance, the one that I just drew, and we can straighten it out if we would imagine that it would be an actual string that's, very loose, okay? And we can certainly, it's not very rigid, okay, like a box, okay, of something which is solid. Okay, so maybe it's much looser. And we can actually extend it and we can create, a straight line. Now, those are all distances that you are kind of aware of. And then the actual path that you're taking from one point to another, okay, will of course depend on what exactly it is that you're measuring. Now, the key thing is that these are distances of indeed, okay, paths from one physical point to another physical point. The other point is that as you're measuring this distance, it is one-dimensional. Now, what is exactly that one-dimensional? Well, luckily, because you are, okay, at least in grade 10, 11, or maybe beyond, you've heard of one dimensions and you've heard of 2 dimensions and 3 dimensions. So if you think back, okay, in terms of one dimensions, so if you have a, let's say, okay, you would call this kind of the old school, and you would say that you have this line, okay, which is your number line. So this would have been a one-dimensional number line that you're carrying through. Okay, and you can certainly graph things in here. You can take your line, right? You can extend it and lie it down, so I can, for instance, take this width right there and, so let me duplicate it. And let's say that, it started all the way over here, okay, right there. And now I can measure, how long that particular distance is. So I can compare these things, and these are all one-dimensional. Now, of course, okay, we can also think about 2-dimensional things. So if you would draw out, so if I would draw out 2 dimensions when now one number line is vertical and then another number line is horizontal as you're going through. So maybe this is, your x, okay, so which is just the same x, which would be one dimension, but as soon as we add another kind of vertical, which very often we just refer to this as y, just so that we don't have the same letters or variables, okay, accompanying this. Okay, so within here, of course, you can take these and you can create your 2 points in 2 dimensions, but the actual distance between them would still be one dimensional, because we can always think about, for instance, if I have a point over here and then I have a point all the way over here, so this might seem that it's 2 dimensional. Okay, so here is my distance from one point to another. Okay, so it might be in 2 dimensions that these 2 points live, but the actual distance between them, well, if I would take this line, so I can, duplicate it, and what I can do is, I can change it back. Of course, I can kind of rotate it, okay, within here, and then you notice that, oh, well, I can, again, compare it just to one dimensional. So what is the actual length from those 2 points, right? And then I can count up exactly what that might be. Now, you can, of course, extend this, even further. So you can have the points as we live in our kind of 3-dimensional world, right, that we are in right now and that you're surrounded with. You notice that you can pick any points in 3 dimensions. Now, this one's a little bit harder to try to graph. I'll try to do my best here. So let's say, here's one number line, so just bear with me. So here's a little bit of a 3-dimensional, okay, viewpoint. So maybe this is, your x, okay, maybe this is, I'm going to label this as y, and maybe this is, a z. So these are just 1-dimensional, okay, number lines, and then I have just crossed them so they're at 90 degrees to each other. And I have created a 3-dimensional kind of space around us, which we can now map things onto. And of course, you can, once again, create points in here. Now it's a little bit harder again to try to draw this, so maybe, one point is exactly over here, and, maybe another point, lies somewhere further out. Okay, so maybe, it's over here, and then maybe it's upwards somewhere over there. Okay, and then I can connect these 2 points, okay, together, and then, I'll get my distance. So I think you get the gist that even this in 3 dimensions, I can, of course, take it, rotate it around, and place it on the 1-dimensional number line, and then I can actually measure it out. So I can measure exactly what that path, okay, and then how long, so what's the length of that particular path. So that is, distance as a whole. And of course, we have various examples of these distances, and they can be straight lines. They don't have to be straight lines, right? So they can be, wiggly, okay? They can be circular, but we can always take them from one point to another. And if we kind of imagine we have a string, we can straighten it all out. And again, we would turn it in, and then we can put it on a number line and then measure it. Now, when we do our measurements, okay, of these distances, well, we want to be able to know, okay, so, how long is it? So certainly I can take the 2 lines that I've placed there, the blue one and the purple one, that are on the screen, and I can say, well, the blue line is longer. It's, about maybe twice as long as the other one. And that's all nice, great, and that's a qualitative, right? It's a descriptive way of being able to describe what that length is. One is longer, one is shorter. But in physics, and of course in other sciences, we don't want to just have qualitative explanations. We want to have quantitative explanations. So quantitative, we want to have some kind of numerical values where we can compare them. If someone tells us that something is 3 and another thing is 1, well, we know that 3 is bigger than 1, and it's 3 times bigger. So that numerical value right away tells us, oh, okay, we don't need a qualitative description anymore. We can have a quantitative explanation. And we know exactly what that might be. So for instance, if you can imagine that, I have this number line, and on this number line, as you're going through, so maybe this is the start, let's call this 0. And since it's nicely kind of given out as a grid, I'm going to grid this up, okay, in here. So as you're going through, okay, so right there. And what I'm going to describe that each little piece, okay, of this grid, so if going from one piece to another, so this right here, right, this would have been, let's say, 1 unit. And I can now compare, how many units, okay, each piece is, right? So if I can take this now, I can stack them up and I can say, okay, well, this is 1, right? This is 2. And I'm going to duplicate it, and this, so it looks like it is, 3 units in length. Now, the other one, okay, that I would have, so if I would, do the same, okay, within here. So if I'm going to copy this out again, so if I have, from here to here, let me just kind of leave it, okay, in here. So if this is one particular unit, so let me duplicate it. I can do the same to the other one. So I can say this is 1, right? So this is now 2, okay, this is now 3, this is 4, this is 5. Well, I made it a little bit too big, okay, within there. Okay, scaled it back. This is 5. Okay, and then, this would have been 6. But I noticed that right here, so if I zoom in, it doesn't exactly look like it's 6. It looks like it's a little bit less, okay, within here, because it ends right there. So I can, just dot it down, and then I can measure exactly, okay, so out of this piece, maybe, and then I can take a guess, okay, maybe it's, maybe only 4/5 out of that entire line. So it takes on a certain amount. So I would say that, okay, well, this is, not exactly 6 units, but it looks like it is 1, 2, 3, 4, 5. And then, so this looks, okay, again, you would be just kind of estimating this. So you can say this is like maybe 5.8, all right, not exactly 6. And that's how many of these units, okay, that it would be, where 1 unit is right here. Now, these units that I'm referring to, I just made this up, right? I just said that this is going to be 1 unit, and now I can say that the distance from one point to another, is 3 units, or it's 5.8 units. And 1 unit just means it's a fixed amount that we kind of made up. So if you're thinking about the distances, there are actually many of these units which have been now standardized. We want to standardize just as we standardize certain words that we speak so others can understand, okay, what we are referring to. If we say height, we know what that actually might mean, right? So height of a person, maybe height of a building, and so on. So we have various units that are now associated with measuring physical quantities. So in this case, we're measuring distance, but you can measure any other physical quantities, and you're going to run into that in physics quite a bit. So what are these particular units? Like what is the standardization, okay, of these? Well, a bunch of scientists have to kind of come together at some point and say, well, let's standardize these so that anyone around the world will know what unit is actually what. And then what is the actual length of that 1 unit? And then we can count, right, how many of those units we have in a particular distance. So, if we say 1 is 3 and then 1 is 5.8, we clearly know which, depending on what unit you're using, which one is longer, which one is shorter, and then by how much. And then we can start using, mathematical concepts of addition, subtractions, multiplications, divisions, okay, to treat all of those things. So those units are actually important. Now, for us, so there are certainly standardized units. So in distance, okay, as you are thinking about, you're going to run into numerous units for distance. Now, depending on the size and the scale of the actual distance you're measuring, if you're going to be measuring, maybe if it is a distance between 2 planets, you might use a different unit to measure that because it's an enormous scale. than, measuring a little ant, which might be extremely small. So we actually pick different standards on the scale that we are working with. And that's very common for us to be able to do. So, you most likely have heard, okay, of, for example, a particular unit, which, is maybe a meter, right? So if you're talking about a meter, well, when we say a meter, this really means that it's some kind of a unit that we've standardized, just as we have, standardized, at least in here, that this was a unit. So somebody said how long an actual meter will be. Now, a meter actually is relatively, big, okay? Of course, big in comparison to what you're measuring. Now, if you have something which is much smaller, okay, maybe you're measuring a little ant, you may not want to use a meter because meter might be too big of a scale. Okay, so if you would put an ant, okay, beside a meter, it would look like it's a little dot, okay, within there that you would have. So you might use a different unit for it. Now, in physics, and in particular, as you are studying, okay, kind of physics throughout, there are some standards. Okay, and we have kind of came up with a metric standard, and the metric standard for distance is actually a meter. And then we do attach, things that are called, for example, prefixes. Okay, and for prefixes, once you understand some of the units, okay, those prefixes are going to be easier for you to, go about. And I can put up a link up above there, to metric prefixes. Okay, that you're going to run into. And those you have heard of before even physics came about because you've been studying mathematics and sciences for a while. So some prefixes like centi and milli and kilo. And that is just another scaling factor of depending on how big or how small something is that you're dealing with. So those particular units you're going to be running into quite a bit. And of course, those units, have symbols. And so for us, the meter might have a symbol M. And you're going to be slowly learning all of these, different style of units, depending on what you are measuring. Okay, so that's something that you will have. Now, what's very interesting, that from distance, like as you study distance, which is really just one-dimensional, you might say, well, you can actually derive other concepts, okay, than just, the length from one point to another. So there's other physical things that we may want to be able to measure, and we do use distances for that. So if you scale back into 2 dimensions, so if I'm going to, delete these points, and here, so if I would draw out an actual surface, so you're now no longer just interested from one point to another, maybe you want to have a surface, and it could be, the surface of your face, maybe the surface of your hand, okay, that you have, okay, maybe the surface of your package, right? So if if we take this particular box, we want to be able to see, okay, so what is the surface of the front, okay, of the box, or of the side of the box, or on the top of the box, okay, or maybe it's something completely irregular, so if you have some kind of a surface like this, which of course would be very difficult to measure its actual surface, but we can certainly do it. Now, this is now 2-dimensional. So yes, maybe the outline of this, so if we go from one point and then we go along here, okay, all the way through, okay, so all the way through here, we can measure what that distance is on the exterior. But we can't really do a distance calculation when it's 2-dimensional, because what 2 points are we talking about, right? So maybe if I'm talking about a point here and a point here, so I can certainly go across and measure that distance, but I don't capture the entire surface. So what happens is that we start to derive new physical quantities. So from distance, which is just simply one-dimensional from one point to another, we are going to be jumping into where you can take now 2 dimensionals, okay? So this is in 2 dimensions. If you take a distance and you actually multiply it by another distance, okay? So this would be now distance, which is squared. This actually leads to the concept of measuring the physical quantity called area. Now, very often, sometimes you'll hear the word surface area because it is the surface of something. And now we can certainly figure out, okay, with respect to surfaces, how big a surface is. Now, this one would be very difficult for us to measure because it's so irregular, right? So it's kind of has a lot of curvatures along. But, if you're starting off with something which is a much simpler surface, so let's imagine, I have a box, okay, and that box has a surface which is kind of rectangular, which is a little bit easier to understand, and you can expand that to irregular surfaces as well. So in here, you can say, oh, okay, so I have, some particular surface, so you can imagine that this is one of the distances, okay, which is maybe the width of this. So this would be the distance 1, distance 2. So let's call this distance 1. Okay, and then this right here would have been your distance 2, which is in another dimension, okay, within here. So distance number 2. And now with these two distances, you can also create, these little units, okay, in order to count. But they're in 2 dimensions. So, for instance, you might say, okay, well, let this, because it's a nice little box there, okay, let this be 1 unit of area. So this would have been 1 unit, okay, of area. And now notice that we can't just keep calling it unit. We have to give it a name, okay, and we have to standardize it for the quantity because we can't call everything a unit. So we actually give it specific names. And that's why, for example, for distance, we might use meter, or maybe you'll use inch, maybe you'll use centimeter or millimeter, which you have heard of all of these before, so it makes it a little bit easier when you jump into your physics class. So if this is a unit, right, if this represents, this little square represents 1 unit, I can once again say, okay, well, with this unit, okay, I can measure, okay, right here. So I can say, okay, well, this is 1. Looks like this is 2. Okay, this is 3. This is 4. This is 5. This is 6, 7, and 8. So it looks like if this was my unit of measure, I would say that this, okay, is 8 of those square units. Now notice this is a little square. And for this, maybe this is, the square, and you can imagine this is some big box. And maybe, if we talk about meters, so what you would have is, well, because it's 1 meter in one direction, and then it's another meter in another direction. And if you multiply 1 meter times 1 meter, which would cover this entire surface area. So it just covers that entire thing because you're spanning both across here and across there. So you're covering the whole square. And if you multiply these, of course, 1 times 1 is still 1. That's why it makes it 1 unit. And the unit designation here, because it's m times m, there's 2 of those m's, which we designate with a square. And that little square actually tells us that you are referring to, because this is m, which is distance, and distance squared is 2-dimensional, and it means that it is covering these particular squares of that surface. Now, of course, we can go back to the irregular shape. It will be harder for us to figure out how many of those are, but now we do have quite good enough tools to be able to make these measurements. But that's actually what an area is. So an area is a measure of a 2-dimensional surface that we have, okay? And we can measure it out as we go along. Now, in 3 dimensions, I'm sure that you can now extend this and you can say, well, we don't just deal with surfaces. We actually deal with things that occupy 3-dimensional spaces. right? We're certainly not just a surface. We have a surface, okay? That, there's our skin. You can imagine that it's just kind of rounding around. But even our hand is three-dimensional, right? It occupies a certain amount of space, okay? Our head, okay? Our bodies, the books that we have around, this pencil that we have, the screen you're watching on. So it doesn't matter how thin they make it, okay? It's still not thin enough, okay, to be just a surface. It's still three-dimensional. And in those three-dimensional concepts, okay, as you have, then of course now you start thinking about boxes. And that now takes this particular unit, which went from just one dimension as you went along. So this was 1 unit, okay? You can again imagine that it's a meter, although clearly it's not, okay, within here, although I guess it depends on how big your screen is. So, this might be 1 meter as you go through. Now we've created, okay, a 2-dimensional space, okay, within here, because it went from here to here, so that we cover all of this. Okay, so now this is now creating a little nice box for us. So we say that this is 2-dimensional, so this would have been the area or a surface. And now, of course, we can make this 3-dimensional, so now we have to extend this to the back, okay? And all of these little squares are actually the same, right? So you would have 1 meter in this way, and then you would have also 1 meter, okay, in its height. So this now makes all of a sudden you have your height, you have your width, all right? So maybe this is your width right here, so this is your height, okay? And then maybe this is the depth, all right? So this is times depth that you have in here. And that is now your volume, okay, which is a little bit of a cube that we have in here, and it's 3-dimensional. And certainly, we can take objects and then we can say, okay, well, how many of these units does the object occupy? And depending on the scale, okay, we're going to be using a certain unit. 1 meter, right? So if we would take this and we would say that these are all meters, so 1 meter times 1 meter times 1 meter, well, that would have been 1. Now I have meter, and then there's 3 of them, so we put a little cube there, so that's m, m, and m, so that's 1 meter cubed. And from that would have been a unit of measure that we would have. Now, of course, if you would say you have 2 meters cubed, those are like 2 boxes, okay? 3 would have been 3 boxes. So now that tells you and provides us a quantitative, an actual measured value for the volume. So this is just the introduction, right? So it is meant to introduce you to this concept of distance, that there are many different distances like height, radius, width, okay, depth, and so on. And those distances are all 1-dimensional from measuring from one point to another. But now as you extend this, okay, into 2 dimensions, when you start talking about surfaces, then you run into an area, which may be just the height, okay, and the width or the length of something, right? So it's in 2 dimensions, it talks about surfaces. Then you can extend it to 3 dimensions, okay, as you're going through. So what you're noticing here, I hope, is a pattern. And what I want you to think about is that distance is something that we as humans have defined for ourselves. And we have defined units so that we can measure it quantitatively, not just qualitatively, where we're describing a length of something, but we can give it a number. But then that number has to be having an associated unit with it. Now, from this distance, we've actually we can derive in 2 dimensions the area, which is the measure of a surface, of how big a surface actually is, because it no longer makes sense to be in 1 dimension if we're talking about surfaces. And we can derive in 3 dimensions volume, which measures how much space an object occupies. So those are 3 things that are really useful. So we have distance, we have our area, typically designated with capital A, and we have our volume, typically designated with capital V. So that is one major foundational block of physics that we have now studied, which is distance. And you're going to need that distance, and we're going to be building from this block once we introduce and define other type of physical quantities. Thanks for watching. See you in a future video. Bye, everybody.